everyone. Welcome. This is a special day when we get to have a PhD defense, and I wanted to welcome those of us that are joining by way of the Technology Management Distinguished Speaker Series meetup group as well. So this, when we have a PhD defense, we like to make it as public and available to celebrate the opportunity and share the knowledge gained through a doctoral research. So this is a great opportunity. I want to welcome everybody. And this is the PhD defense in the Technology Management PhD program at Portland State University. I don't want to take any more time, but if you have questions or comments about that program, you're more than welcome to reach out to myself, Dr. Yetter, Dr. Weber, or Chris Davis, if you'd like to hear about his experiences as well in the doctoral program. So without further ado, I'll turn it over to the doctoral advisor, Dr. Antonia Cheddar.
Thanks, Tim. So hello, everybody. As Tim said, this is an exam. This is a accumulating event after many years of very exciting research. And the person defending today is Christopher Davis. I've worked with Christopher on many different things. I think he basically wrote the content for 2 dissertations. I'm excited that this is now coming to closure, and I'm very much looking forward to his talk. And before we give the floor to him, I'd like to introduce the other committee members in no particular order. So one committee member is Dr. Charles Weber, also from Engineering and Technology Management. Dr. Amita Agrawal, who's in computer science at Portland State University, and Dr. Philippe Giabanelli, who is in computer science at Miami University. So thank you all for joining us. And the first order of business is that Chris gives a talk about 30 to 40 minutes. And after this, the committee will ask questions, the public is allowed to ask questions, and then there will be a committee deliberation that of course will not be public. So welcome everybody. Floor is yours, Chris.
All right, thank you, Antonia. All right, let me just set my presentation up here 1 second and get my Zoom screen back and share my screen. And all right, there we go. Welcome everybody to my PhD thesis defense. Excited to see you all here. So the title of my defense is, or the title of my dissertation is Automated Scenario Planning with Natural Language Processing and Fuzzy Cognitive Maps. So that's a mouthful, but essentially this research, wait, hang on a sec, let me move this Zoom window out of my way here. Okay, but this research uses automated modeling to help product development teams use strategic planning in agile processes. So to start it off, I'm actually going to start off with a little bit of a story by painting a picture. So imagine this, come on, Zoom screen, get out of my way. Okay, sorry. So imagine, if you will, a fictional product development team, and they find this big opportunity in the field of port operations. They think it's a great opportunity to build a digital product. So they decide to do this strategic ideation up front. They do this very strategic planning using a popular and effective technique called scenario planning, where they do a lot of research, they consult experts, and they work together to really come up with these multiple possible futures that their product will live in. And so they kind of look through the cone of uncertainty, they aggregate all this research, they consult all these experts, and come up with these potential futures. Now, this team using this technique comes up with a great idea. They're really happy about it. And the scenarios that they looked at, in this case, had 2 major driving forces that kind of inform their scenarios. One is the major changes in demographics of the workforce. And second is the rapidly increasing pace of technology that could be used. And based on all these scenarios, they decide the most plausible one is the scenario 2 over here. And they imagine in the future, there's going to be plenty of well-skilled staff. Technology is going to continue to play a key role in this field. And so they designed a product that is really kind of shooting for that specific future. And they get to work, they agree on what to do. And as happens really quite frequently today, the team's given autonomy and they start using these agile processes to develop their product. And with agile, kind of the big thing they do here is they flip the cone of uncertainty. So instead of looking ahead and saying, well, all of these things might happen, they say, we know a lot of things aren't going to happen. We know we're not exactly sure what we're doing. But then they use these iterations to hone down on a specific customer, a specific market, a specific product, until they have very strong target customer, somebody that they're working with very closely, and they continue to make their product better and grow their market share. And so sounds like a nice story. The team built a successful product using the latest methods and management. Everybody's happy. And this is a fictional team. However, this scenario did come from the literature. This was done in 2015. And it was funded by the German Federal Ministry of Education and Research. And they wanted to understand, how can we create policy to enable better port operations? And if you imagine this team working for a customer really squarely in this scenario, they could be very sad today if they took about a year or so to build their product. We ended up 7 years later, ending up in this worst case. It's common knowledge today that port operations are quite bad. They're suffering. There's not enough skilled labor, and technology really hasn't taken off there in the way that we thought it would. Now, this is a bit of a dramatization, but it's not uncommon for teams to do this very strategic envisioning up front, only to lose sight of the big picture when the larger environment around them changes, as they gain this stronger focus on their specific product, customer, and market. And that happens because they're down here in this little bubble of their organization, but their organization is part of this larger transactional environment with clients, competitors, partners, suppliers. And even that is part of a larger contextual environment with these pestle features of political, environmental, social, technological, economic, legal. That's pestle. And when teams end up in this world of hyper-focus, they tend to suffer from what's known as group process loss. So they suffer from groupthink, and they lose sight of this big picture, and oftentimes end up focusing on outputs rather than outcomes. And so, what if we could take this larger thinking? What if we could aggregate a lot of this information and bring it down to product development teams so they can have this broader strategic outlook as they're developing their product in a more agile way? And understanding how we can bring that overarching strategic thinking to fast-moving teams is my research objective. And I do that by developing and evaluating scenario acceleration through automated modeling, which I will affectionately call SAAM. And I use a research method called design science research, where I've built an artifact in software and have studied it in context by validating it with several different experiments. So I'll dive more into this artifact later. I think a few key things to take away here, so you don't get completely lost with my acronyms. Some key acronyms that we'll be looking at are natural language processing, which is NLP, fuzzy cognitive maps, which is FCM, horizon scanning, which ends up being HS, and of course, scenario acceleration through automated modeling, and that is SAAM. So for the rest of this dissertation defense, I'll give a little bit more background, and then I'll talk about SAAM, which is the artifact. And then I'll dive into 3 validating results that I use to show that SAAM is potentially useful, and then wrap it up with a conclusion. So firstly, if you're out there looking at this and saying, well, scenarios, why scenarios? And well, when teams use data to construct and to think about plausible futures, they gain this host of cognitive benefits that are demonstrated throughout the literature. Anything from managing uncertainty, making better decisions, breaking away from groupthink, reducing bias, improving the market success of products. So all very important things when you're thinking about developing new products. However, these product development teams don't use scenario planning often because it's a very heavyweight and expensive process. It takes often experts from outside of the organization to do a lot of research and give a lot of input. Experts will then aggregate all of this data that they've put together and conduct these long workshops. And oftentimes they'll create a model. And even when they create a quantitative model, and will be kind of focusing on quantitative models in the scope of my research, then they typically only use it once. And they set their direction and they go, and then the model's really left by the wayside. To put this in context, if we look back at the scenario of the smart ports, in that study, they had 16 domain experts that they had to bring in. They had a consulting agency that helped run the whole thing. They had over 20 stakeholders that they brought into these workshops. The workshops lasted 5 days, and everyone had homework at the end of every day. So that's just one example, which is very common in building scenarios. And so what this ends up causing is this disconnect between strategy and execution, where up front, these teams do this strategic planning and ideation, but then over time, as they iterate on their product using agile processes, which are great for managing change in the present, they don't bring that future thinking forward. And a lot of those benefits from scenarios end up getting lost over time. And so, in summary, there's a few key gaps that my research addresses. Firstly, scenarios are expensive and they take a long time. And this makes them inaccessible to modern product development teams. And then secondly, even when they are used, they're really only used in the strategic phase because they don't fit into these agile methods. And so if a team did take a scenario, and even if they had a quantitative model that they used over time, because they're not updated, they become irrelevant to decision-making. Thinking back to our smart port team, they could have taken those scenarios and just, kept them pinned on their wall, but driving forces changed kind of the direction of the future, and those did not end up being plausible in only a few years. There's a few different solutions that could be applied to this problem. Firstly, is the fuzzy cognitive map, which is used to build quantitative scenarios. So fuzzy cognitive maps are a type of model that can be used in many contexts. In particular, they fit here because they've been used to build quantitative scenarios throughout the literature. And their models, so what is a fuzzy cognitive map? They're models comprised of nodes or concepts. That's what a C is, it's a concept, these little bubbles are concepts, and relations between them, indicating if concepts have a positive or negative effects on the other concepts. And then you can build these very visual, human-friendly models, and then run them as mathematical models as well. So, again, the smart port example, one concept could be the adoption of automation. One concept could be the age of the workforce. Another concept could be the speed of delivered goods in the supply chain. You can have as many different concepts that you want to create potentially very complex models, and then run simulations with them to see, what if the age of the workforce decreases, run the model, and you can see how it affects all of the other nodes, in this case, particularly the speed of delivered goods. So what happens if we increase automation? You can run the model and see how it affects all of the other concepts in the model. So fuzzy cognitive maps are great for building these quantitative scenarios. And there are a handful of studies out there that build fuzzy cognitive maps with natural language processing. So NLP is a very natural interface where machines can have very human dialogues. They allow you to interact with data in a very natural way. For example, you can simply ask a question of a bunch of data, one method called the Q&A method, question and answer. So it is possible to use natural language processing to ease this burden of research, to analyze large amounts of text faster. So then ultimately, when we look at these bottlenecks in the process, we can use natural language processing to help speed up research, conduct analysis. We can build models with fuzzy cognitive maps, and we can use those models over time to help keep our eye on the most potential plausible futures. And if we are able to do this, then we can go from this very static scenario usage before product development to a more dynamic usage of scenarios where you can still use scenario planning up front for your strategy and ideation, but as you're iterating through your development, you can keep them updated so you can continue to use you continue to gain these benefits of strategic thinking over time. So, we know there's this disconnect between agile teams and strategic direction. And we know that there is technology that can help. Now, how do we bring it all together? Which that brings me to my research questions. Firstly, using natural language processing, how can we extract the drivers and interdependencies from text using a Q&A type method? Secondly, how can we take those drivers and interdependencies and build them as a fuzzy cognitive map? And then thirdly, okay, if we can get everything we need to build a model, we can build a model. How do we keep the model up to date over time? Going back to our steps of the scenario process, my first research question really looks at easing the burden of research. Secondly, we're looking at building and using this model. And thirdly, really looking at how to keep it up to date over time. So there's a lot of stuff going on this diagram. Essentially, this is going to be our guide map for the rest of my presentation, where to test if this technology can be applied to these questions, what I've done is I've assembled all these potential solutions into a conceptual system, which is SAAM. And then I test various pieces of it using design science research. And in design science research, you use your artifact and context to answer your questions. So in this diagram, what I've done is I've aligned my questions with the major parts of SAAM and the experiments that I use to validate those parts of SAAM. So if we, we'll take a close look at these as we go through these pre-validating experiments. And one thing to note is that each experiment uses a very specific data source to test a very specific part of SAAM. And we'll take a look at that as we go through as well. So 3 different experiments. Firstly, given that people are used to create these models in typical scenario planning today, really, can SAAM create models as good as a person would? Is the question. As with any type of artificial intelligence, the question is it as good as people or better than people? So here's my first question. How can we identify drivers from a diverse knowledge source using a Q&A method? And there, of course, we get data. Okay. All right.
Sorry.
My wife just broke a lamp in my office. Okay, that's good luck. Right. Now it's just, you can sit down. Okay. And my experiment here, I'm going to talk about what I did in just a second. So the data source that I use here is particularly suited for testing if SAAM is as good as people as building this model. In the study that this data source came from, 5 people read a single 46-page report about obesity. And then they built a fuzzy cognitive map built on their interpretation. Now, in the original study, the hypothesis was that modelers will bring bias in creating these models, and thus, even if you give the same instructions and the same text to 5 different people, they will create 5 very different models. So even though this isn't related to scenarios specifically, this data does show how people create models from text. It gives a good variance of different models that people have created. And since what we're doing is essentially the same thing, where in this data source, you had people were given text, ask questions, build a fuzzy cognitive map. There's the same exact thing SAAM does, so it's apples to apples. Get SAAM some data, ask some questions, build a fuzzy cognitive map. And so throughout this experiment, first collecting data, secondly, I used 2 different questioning strategies to build my models. So using a Q&A type method to build these models, and if you're asking questions, how you ask questions can be important. So I asked questions in 2 different ways, and then I ran 3 different tests to compare SAAM's results against the people's results from the original data source. where I did a network metric comparison. That was from the original paper. And fuzzy cognitive maps are network diagrams, so network science is really good at comparing different fuzzy cognitive maps. Secondly, a semantic comparison, really looking at the concepts identified if they're the same across the different models. And then finally, because fuzzy cognitive maps are dynamic models, I ran a dynamic test to see how consistent the outcomes of the models were. And so the hypothesis is here, the SAAM should be able to create models that, from a technical perspective, fall within the bounds of those created by people. So the question strategies I used, firstly, which I call SAAM 1, which is kind of the first model. I did what I called informed questions. So to create informed questions without reading the entire text and then coming up with questions, which would completely defeat the point, I pulled out the headlines and I just rephrased the headlines as questions. So this text had very clear, big, bold yellow headlines. It was very easy to just pull them out quickly. One example of that would be human and societal consequences of the obesity epidemic. Just manually created a question, what are the consequences of the obesity epidemic? And I did this for all of the headlines inside the text. And then secondly, what I called naive questions, where I just start from the top. We know the text is about obesity. So I just ask, well, what causes obesity? And then what does obesity cause? And when we design questions like this, we know what the subject is already. What causes obesity? Well, the subject is obesity. So whatever comes back as the answer from our NLP algorithm, we can say is one concept, and it has a positive effect on obesity. Then you can flip it the other way around. What does obesity cause? Where obesity is the cause, and then whatever comes back as our answer from our NLP algorithm is the effect with a positive effect. And then for both models, I did a round of follow-up questions to build a more robust model. And so to do this, for each concept identified for our natural language processing, I took that concept and then I simply asked, what causes the concept to increase and what causes the concept to decrease? Thus, the subject, again, is the concept that came back from our NLP, and the effect is either positive or negative. Now, I think, firstly, it's important to note that of the two models of SAAM, they both fell within the bounds of the models created by people. So there were no major outliers from this model. So from one side, you could say, okay, well, SAAM falls within the bounds of people. It's not indistinguishable from a network perspective. But I think it's more interesting to really compare how the two different models of SAAM compared to two specific people. Because if you look at these numbers, you can see there's a pretty good range of nodes, edges. Density and cycles really talk about how complex the model is. And so for our informed questions, where we pulled out very specific pointed questions, the first model of SAAM, as you notice, was very kind of similar to B in that you same number of nodes and edges, similar number of nodes and edges, not a dense map at all, not a very complex map. So you can see here that this really represents kind of one way people approach the problem, where if you say, okay, what are the causes and effects in this document? They'll find the causes and effects of the document. Whereas if you look at the second model of SAAM, where we're looking at starting it with those naive questions and then drilling down, we have a much more complex, a more dense model with more edges than nodes and a high number of cycles and density. So again, kind of the two different question strategies reflect two different ways that people went about solving this problem. And then secondly, now there's lots of colors and numbers. I'm not going to go through all of this. I think if you look at semantic similarity, I use two different methods here. Firstly, cosine similarity, which measures kind of get the context of words. So for example, food and foodie would be different. Food and dinner would be similar. With Levenstein distance, we look at how similar the spelling is. So food and foodie would be very similar. Food and dinner would be dissimilar. With the idea that, let's see if SAAM's pulling out the same concepts as people and correlating those to each other. And the overall average is maybe a little misleading because the two versions of SAAM are so highly correlated that they kind of water it down. So if you only compare people against people, and you only compare one model of SAM against all the other people, you'll see that the people typically are more highly correlated, pulling out more of the similar things than SAM, with the exception of this outlier right here. But I would argue that's not a failure, because when we look at the consistency when we run our models, now in this case, we're working with a corpus that defines these complex relationships between obesity, society, the economy, public health. And fuzzy cognitive maps are tools that can be used to model this complexity. That's kind of what they're used for. So in theory, if you run a model with certain inputs that are reflected in the corpus, and the outputs should also should reflect the corpus. And what we see with both models of SAM is that they're both higher than all of the other people in the study. If we look at our naive questions, that is, I would originally consider this significantly higher than the corresponding person. But then when we look at the more pointed questions, we see it's definitely significantly more consistent than the corresponding person. And so what we can conclude from this first experiment is that despite the type of questioning, then SAM can create models that are comparable to people from a network analysis perspective anyway, yet are much more consistent, reflect the text better than the people did. You could argue that this is further validation of the hypothesis from the paper this data source came from, which was that people bring bias, to this modeling exercise. And so perhaps using automation can help remove that bias. So now moving on to my second experiment, the data source here was about the potential future of electric vehicles, which is what this snazzy picture represents back here. So, all right, sure, we can build a model. Great, research question 1, check. So if we can build a model, really, can we use this for scenario planning? Can we generate alternative futures that are decision relevant? And so for this, I used a different data source, where in the original study, the authors use a different type of natural language processing. So what they did is they said, why would we do all this research ourselves? There's all of these websites out there that do all of, aggregate all of this future thinking, put it all together and publish it. So let's just scrape those websites and we'll build a model with it. So that's what they did. They scraped what they called futuristic websites, which are websites that were making predictions about the future based on data. In this case, it was specifically about electric vehicles. And they used a type of natural language processing called latent semantic analysis, LSA, which is also known as topic modeling. And what LSA is very different than kind of the Q&A method that I'm using. With LSA, you find groups of words used together, and then you label them into groups. And then they use basically market basket analysis to find correlations. So if you think you go to the grocery store and they can figure out who buys what with what, and really that's from kind of looking at things in a shopping basket. They did the same thing with the documents and their terms. So they used a very data science heavy process to build these models. And then they ran 4 different plausible scenarios, what they considered plausible scenarios, to determine what's the potential future of electric vehicles. So in this experiment, I collected the data from the previous study, doing the same scraping that the original authors did. And then I built a model using a different question strategy again, this time using PESTLE-based questions. So remember, PESTLE, political, economic, social, technological, environmental, and legal. And the original authors really had that lens, when they were looking at these. They were looking from those, contextual factors. And that's actually quite common in scenario planning also. So it's a good test for this questioning strategy. And then secondly, I ran simulations with the model that SAM created, and I compared the output to the models from the previous study to see, okay, well, if they created these 4 different plausible scenarios, what scenarios can we come up with SAM? And so just to zoom in on one concept. So they had multiple categories that they found in their study. So the concepts that they grouped into what they called government regulation were over here. And then SAAM identified several concepts. And so manually to compare these together, I labeled these similar concepts as government regulation. And then I ran this, deregulation was one of the scenarios. I'm just going to focus on one of the scenarios from this study for the sake of the presentation. But removing regulation in the original study, their plausible future was, well, if the government relaxes regulation, then safety will increase, energy efficiency will increase, and cost will go down. And their model reached what's called a stable state. So this is a simple example. There are multiple ways when you run fuzzy cognitive map simulations that the simulation can turn out. And one way is a stable state where the variables play off each other in such a way where eventually they reach kind of consensus and they stop changing significantly. Another potential output is what's called a cycle state, which, this is a simplification, but in general looks like this, where the variables play off each other in such a way that they never reach a stable state. They end up reaching this cycle state. So when I decreased government regulation, SAAM fell into this cycle state, showing that if you decrease regulation, then it's extremely difficult to figure out what the future is going to be, because all these variables will constantly play off each other and you'll never find a stable state. Then this is interesting because these represent two completely different social philosophies. And any team that's developing something in the space of electric vehicles, they're going to make very different decisions based on whether they think the environment will become stable or not. And then also, I think if you ask most economists, they'll tell you that the whole point of regulation in the first place is to create stability. So deregulating and creating a stable outcome from that is maybe not as plausible as the original authors intended. Regardless, I'm not saying that one model was better than the other. The conclusion really here is, based on running all of these different scenarios, we can say that SAAM creates these models from last experiment as good as people. And then here they can create these very plausible, thought-provoking models, which is kind of the whole point of scenario planning in the first place, to help provoke thought and keep that strategic purview open. And in the final experiment, I used horizon scanning. We'll talk about horizon scanning in a second to see if we can keep these models up to date. Now, right, we know we can build models, okay, great. We can build plausible futures, okay, great. But we still really haven't looked at how we keep these models up to date over time. So here I used a third data source. Firstly, I used the same model that I built in experiment 2 around the future of electric vehicles. And I also used a newsfeed data source where, there's a project called the GDELT project that aggregates news from all over the world from all kinds of sources. And it's an accessible public data source. So I went back and I pulled a few years of data from there to run horizon scanning on it. And what I did was, if you take this model that we built to look at the future of electric vehicles, and so that was in 2016, and you fast forward a few years and run horizon scanning with terms or like terms from the model that represent concepts of the model, can we get data from horizon scanning to help improve our model, potentially rebuild it over time, and make sure it's a good model, or maybe even rebuild it. And so my hypothesis here was that we should be able to use horizon scanning to help inform rebuilding these models. So a couple quick important things to know about horizon scanning. There are at least two major things that horizon scanning look at. First, here on this y-axis, you have the growth rate of a term or a signal, and that's indicating how fast something's growing, which is the frequency of it being talked about in whatever your source is. And second is diffusion or frequency, and that is how many sources are talking about something. Typically, horizon scanning looks for these weak signals. So a weak signal is something that's growing rapidly and not many people are talking about. So the idea is that you can learn about it before other people do. You can find this weak signal on the horizon. Something that's a growth leader is something that's growing rapidly and everyone's talking about. So it's something you probably missed the boat on. And then pretty much anything under this line here is considered noise. You know, stable areas are things that everybody talks about, but it's not growing. And these niche, oh, I didn't fix it fully on niche, sorry about that. But the niche, so don't let the term niche fool you either. It really essentially that means there's a subset of people that talk about it, but it's not growing. And if we look at these concepts of our that represent the concepts of our model, we can see that in this original data source, they cared a lot about electric vehicles, pollution, the economy. And when we horizon scan on terms around these concepts, we can find that they're not growing. You know, they've reached a stable state. I think if we look at the state of the world today, right, this data was between 2019 and 2021. Every major car manufacturer has an electric vehicle. It's not growing. It's certainly not emerging anymore. It's here. But one of the concepts that were identified was around self-driving vehicles. And maybe in 2016, that was really far out. But now when we see this in our horizon scan, we can see this is starting to grow more rapidly, yet not many people are paying attention to it yet. So this gives us really an opportunity to look at these results of horizon scanning and rethink the edges and our weights in our model just based on kind of simple data that comes back from our horizon scan, where we can rethink the edges and the weights of our model against trends that we're seeing in the environment. Potentially even deciding, well, if electric vehicles aren't growing and self-driving vehicles are, maybe we should just throw our old model out and build a whole new model. If we can do that with automation, then we can do it really quickly anyway. So this experiment showed that, yes, we can use horizon scanning based on the outputs of our fuzzy cognitive maps to keep these models up to date over time. Teams can continuously use them. So overall, summary of everything that I've done and talked about here. Firstly, I have set out to develop and evaluate scenario acceleration through automated modeling, and check, yes, I did that. Built it, I've demonstrated it. Secondly, based on my research questions using design science research with SAAM, can we use natural language processing to identify drivers using Q&A? Yes, check, we can do that. We can also model them as a fuzzy cognitive map, and we can keep them up to date with automation over time. And so as a whole, this research addresses these gaps in the literature around that we can accelerate scenarios using fuzzy cognitive maps and natural language processing. And we could potentially then use this to address those side effects of autonomous teams by fitting them into these very agile methods through automation. And of course, I would argue this is important research because by developing these methods, firstly, I've detailed a novel method to combine horizon scanning with fuzzy cognitive maps. And then by creating this novel method of building fuzzy cognitive maps with natural language processing, we're able to then bring these scenarios to a much broader audience. I like to say we're going to bring it out of the boardroom. We could bring it to any fast-moving team. And we can build these fuzzy cognitive maps from disparate data sources. There are multiple attempts in the literature to build fuzzy cognitive maps automatically, but there's no standard there. So this is a contribution to the fuzzy cognitive map literature and to the academic research on scenario planning, as well as, I haven't talked about this so much, but this system is a socio-technical system. It's people and artificial intelligence working together, which falls within the realm of interactive machine learning. And this novel approach helps bring it together so people can be augmented with artificial intelligence and they are better together. And then finally, if we think back to our product development team from the beginning of this presentation, this research defines a practical way for them to make better products. And in fact, it could help any team think more strategically. And hopefully, if they're considering all of those contextual factors that, sorry, a little cheesy, they make the world a better place. Okay, so thank you, everybody. And just a few acknowledgements before I turn it back over, since I'm a few minutes under. Firstly, I just wanted to thank my wife, who's over here, even though she broke a lamp in the middle of my presentation. I know it was out of love. She was trying to get my lighting better. Hopefully my lighting looks really good now. And was kind of supported me throughout this whole thing. And of course, I need to thank my committee. Charles and Amita given so much great feedback and helped me with this. Philippe has, over the last few years, made me a much better writer and presenter, plugged me into the modeling community. Really appreciate all of his mentorship. And then, of course, Antonia has been an amazing mentor and chair of my committee. So thank you so much. And then also Dr. Anderson, the ETM department. I've learned so much in my time here. And then finally, it looks like there's a lot of people that have showed up for this public defense. My friends and colleagues that have supported me through the years and believed in me. Thank you so much. I appreciate you all. And in case my parents showed up, I love you guys. And if it wasn't for you and distilling the need of education as a young child, I would have never made it here either. Okay, so having said that, I will turn it back over to Antonia.
Thank you, Chris. Congratulations. I thought this is a super clear presentation, and I really, really enjoyed it, the way you laid out multiple years of research and lots of different ideas in a very, very coherent and exciting process. I think I have one question, and which is typical for any defense. So what's next? So you talked about SAAM being a socio-technical system, and you've done the very important first step to develop the technology and to test it on already existing data sets. In your vision, what is the next logical step to get SAAM to being that vision that you've laid out, this tool that takes scenario planning out of the boardroom and gives it to any agile team on the planet to make a better world?
I think this research could be taken in a number of different directions. I think from a research perspective, maybe the next logical thing would be to use it with a real product development team. All of my research was around testing it to make sure the artifact actually worked. But I in my opinion, I think that this, because ultimately what we're doing here is we're distilling knowledge in in a different way, building these, very quantitative scenarios and bringing them down to either fast-moving teams or really anybody who wants to make better decisions. So I think what's next, for me, of course, I will continue to develop SAAM and harden it and make it a better artifact. But I think, using this method and really testing to see how fuzzy cognitive maps can affect people's decisions, regardless of context, I think would be really important to understand. But even though, as you know, fuzzy cognitive maps are becoming more and more popular in the literature, but I think they could benefit from a lot more practical research to understand how people could use them more in context.
If you want to take a wild guess, where do you think this might break in practice? Where might this method run into difficulties with a real world team?
And this is kind of just based on my experience with agile methods. I would imagine, as with many teams, potentially they get under so much pressure to deliver. And then really this is part of the problem today, but they don't take a step back and look. They get so hyper-focused on their one, little bubble that they're in, they don't take a step back and approach it. So I think, the worst case is that people that are just so into their routine that they don't, they don't try to use the method, or they potentially pointed at data sources that are irrelevant, or, it could be difficult to get data for very future-looking spaces, especially if you're building a new product. You really need to think about where you're getting that data from and access to it to build a good model.
Thank you. I'd like to open it up to the other committee members, so you can simply unmute yourself.
Okay, I'm unmuted. Can you hear me?
Yeah.
Mm-hmm.
Okay. Yeah, you first of all, great presentation. It increased my curiosity. There were a few concepts that you glanced over, essentially for the reasons of time, presentation time. One of those was the Levenstein distance. I'm not that familiar with the details of your work. Can you explain to us what this is? And
Yeah. So Levenstein distance, what it does is it measures, it's very popular to measure the similarity of words. And what it does is it measures kind of the like number of letters in sequence of different words. So kind of, yes, I zipped through this, but as an example, if you look at the two words like food and foodie, like a foodie is someone who loves food and they talk about food, but they are not food. Hopefully no one would eat a foodie. But if you use Levenstein distance, Levenstein distance will say, well, these are very, very similar words. They're spelt similar. In fact, one is a subset of the other word. So these words are very similar. Whereas if you take food and sandwich, they're completely, spelling is totally different. One word is not inside the other. So Levenstein distance would say, these are two very different words. Because it's comparing, the spelling is comparing the letters in the word. And there's a complex formula on how to perform Levenstein distance. Essentially, I mean, I don't want to say I cheated, but there's common software libraries to calculate it, which is what I used. But that's essentially what Levenstein distance is.
okay, thank you.
Yeah.
So I'll ask something just for the ritual of asking something. I love the example of eating a foodie, though that'd be the first thesis defense that ends up in cannibalism. So the question for the first case study of SAAM, so you show that SAAM 1 looks like one person, SAAM 2 looks like a different person. And I thought that was a great new slide. So I was really excited by this analysis I haven't seen before. Do you think that you could tweak SAAM to follow the strategy that others could use, like student 3 or student 4? Are there parameters that can align SAAM to be more like this person or that person? What do you think?
I think, so what's really interesting about that question, and what was interesting too about these results, is they reflect two different, so you ask a group of 5 people to do something, and 5 people take a different approach. They may all build something, but they do it a different way. And what I uncovered with these 2 different question strategies was I really uncovered 2 different ways that people thought about the problem. Because by asking very specific questions based on the headlines, SAAM just went through and picked out, okay, these are causal effects throughout this document, but not related to obesity. It kind of made the assumption that everything was about obesity and just these things cause each other. So whereas with the other one, we're really looking at what causes obesity and then cascading down from there and what are the effects of obesity, then that is really a different way to frame the question in someone's head, where someone can look at this and think, well, this is a document about obesity, and so I'm going to find not only the causes of obesity, but then the causes of those causes to really build this kind of rich model. So I think, kind of after discovering that, the question then would be, can we really uncover how these other people would go about solving this problem? And I think, potentially using different questioning strategies, that we might be able to, reflect different people in the model. We'd have to I would imagine there'd be some trial and error around figuring out different question strategies to try and think through like how people would think through the problem. But I certainly think it's possible. And this is something I really found fascinating about it too, is that, over time, potentially if this method, caught on, and you could even think about what kind of model you want to build and design your questioning strategy based on the model that it could come out with.
So follow up in the end for me. Your tool has a bright future in terms of the workplace, as a potential follow-up study that you just mentioned a few minutes ago. Other potential uses could be about learning to model. So for example, you can figure out when a student models whether he or she follows the strategy that had to be followed, or a different one, and maybe you can make suggestions accordingly. So how do you see your tool as a potential educational tool for modeler? Do you think there is a potentiality there? Is it of interest? What are your thoughts?
Oh, I absolutely do. So I'm going to use an analogy from the literature. As Antonio said, I think I probably wrote 2 dissertations writing this dissertation, but one of the fields that I really dove deep into was interactive machine learning, where the whole idea was, that people and artificial intelligence make each other better and learn from each other. And this one study that really resonated with me, because I'm a musician, I've got guitars here, was that this one study used cellists and machine learning, where the machine learning critiqued the cellist, or the cellist was supposed to tell the machine learning, here's what I'm doing, and then they play something, and eventually the machine would learn. But then over time, they realized that the cellists were also learning from just the questions coming back from the machine, and they ended up creating this kind of feedback loop where they were learning from each other. And I modeled this using interactive machine learning, really with that whole concept, because when you look at scenario planning, you have these long workshops, and you could argue that, well, maybe it's getting people together and thinking through the problem that causes all of these benefits. So I think that absolutely there's room for teaching people how to model better or doing better modeling, especially if you focused on it from that interactive machine learning perspective, to use kind of people in that question answer method interacting together, seeing the results, and then tweaking them over time to understand, how your thought process affects the model.
Thank you.
Excellent presentation, Chris. I really enjoyed it. I was just curious about, there was on slide, one of the slides you showed that there was a cycle state, and then there was a stable state, and then the human scenarios reached a stable state, whereas one of the SAAM models was in the cycle state, unless I misunderstood this. But let's say different models output different states. Which one is more desirable? Is it the stable state that is more desirable to be in, or would you like some stochasticity in your model? And so any insights about that?
I love this question. So this is, I'll try to just answer this succinctly. I think one of so actually too, one just quick correction. The model that SAAM was compared against there was actually created automatically by data scientists. So they ran these very data sciencey processes and created a model. And I think, from a scenario perspective, the whole point of scenarios is to provoke thought and make you kind of think about the plausible potential future, so you can then, not predict the future so much as, be more open-minded as you're marching towards it. And so I'm not sure if there's a desired state. Well, maybe I would argue probably most people would want to have a stable state, because then it's easy to say, well, when I run this what if scenario, I get this very discrete outcome, and then I can easily say that this happens and this happens. So I think things that fall into a cycle state are a lot more cognitively challenging. It really kind of makes you think, well, okay, if we decrease regulation, these things fall into this weird cycle. How do we even manage for that? It's much more difficult to think through that problem than it is to think, oh, well, we just need to convince our politicians to get rid of regulation and everything's going to get safer and energy is going to improve. So I think from a scenario perspective, the good open-minded user of the system probably shouldn't care if it ends up in either state. But I would argue, in fact, I know for me with my own modeling, I really like when things reach actually, no, one thing too, I'm going to retrace my steps there. It's nice when things reach a stable state. But one thing that fuzzy cognitive maps is used for commonly is in environmental modeling. The old analogy is like the predator-prey model, where it's like, wolves, there's a whole bunch of deer and there's not a lot of wolves, and there's a lot of wolves and not many deer, and the wolves die off, and it's kind of creates this cycle. So this fuzzy cognitive maps is used a lot in different types of environmental modeling. So I think, there could be instances where maybe you are looking for some type of cycle or some type of balance, and, potentially trying to find the way that either you could benefit from that, or you could cause some fortuitous cycle by changing, somewhat of scenario. So I think, to, come back all the way back to like, it depends, but I do think it depends on kind of what you're trying to model. And then hopefully, modelers would, or recipients of the model would be in a mind frame enough to not care if it came one way or the other.
I see. Yeah. Okay. So yeah, I understand. And that's interesting. Basically, so you are sometimes looking for these challenging scenarios so that you can then make your policy decisions accordingly. So
Yeah, definitely.
One other question I had was the horizon scanning that can then help you improve or modify your SAM or adjust to it according to the evolving situation. How often do you think horizon scanning should be done? Is it every 3 months, 6 months, 1 year?
The cool thing about horizon scanning is you can just run it continuously because it runs on current event data. So in my experiment, I've got historical data and I ran it across that data. And then to play with it for a while, I continually ran it over time to see, how did these, how fast did these things change? I think, so you've read my dissertation, but in the dissertation, which I don't actually cover in this presentation, I show kind of how the people recognizing viruses came through the horizon scanning signals when COVID hit, where it started off as this little blip, kind of exploded, and then moved over into this niche area. So we can kind of see how that cycle works. I think if product development teams were going to use it, then I think it's important to look at it based on the cycles of their development. So if you have a team that develops every 2 weeks, then I would argue, do your horizon scan every 2 weeks. What's interesting about horizon scanning is it's a constantly changing thing. Or another way to think about it is how frequently your data source refreshes. So I use news data source, which is constantly refreshing. If you use GGL data every 15 minutes, you can get tons and tons of data. But if you're doing something in a much more closed area, let's say you're just concerned about machine learning, and perhaps the news is completely irrelevant because probably most people aren't talking about machine learning, so you're just going to get a ton of noise. So for that, maybe you want to scrape a subset of academic journals or very specific websites, and they might not refresh as frequently. So then you may, based on the frequency of the data source, do your horizon scan on a less frequent basis.
Yeah, that's really good to know. Yeah.
A little bit along the same lines, Chris. So I think you've very clearly shown that the whole idea is to challenge thinking and to kind of get rid of this tunnel vision that happens to teams. And you did this using technology with certain data sets. And clearly the technology can only extract what's in the data set. So what are your thoughts on finding the appropriate data sets? Because the selection of sources very much determines what you can uncover. And to your point, horizon scanning with news event, well, by the time it hits the news, it's already there. It's already a news item. So any thoughts on how you could maybe push the envelope and use something like horizon scanning to help you find the right data sources?
Excuse me. Yes, I think that initially, I think when I first started off on this research, what I did was I just scraped data from electronic books, kind of with the idea that, if we're building a model, potentially people have already done this data analysis, they've written things up, they've been peer reviewed, they've been edited. So you can build this knowledge base based on data that exists. For horizon scanning, I think, and I haven't run experiments on too many different data sources with horizon scanning, but I definitely think that, even if you look at, Scopus, all of the science articles in Science Direct, there's tons of different journals and different categories that you could use to do the scanning. Or even if you look at all the different journals out there, you could use academic publications to find these weak signals and then follow up from there. It's just interesting. There's so much different data out there. I think that is certainly one of the challenges. This is one of the challenges that I encountered, was just thinking, well, what data source do you start with? If you want to talk about, if you're looking at, food supply chain, for example, who's talking about that? Where is the data on that? How is that even modeled to begin with? So I think, those were really kind of the sources that I looked at. I looked at really academic literature as this very future forward literature, things that are kind of early on that nobody's picked up or done anything with. And then you have, yeah, the news is kind of the opposite side of the spectrum, where it's extremely frequent literature, and it's things that are moving very quickly, often on a multiple times a day. So I guess, I mean, really though, I think, hopefully that answers the question. I think, if you can, and actually another challenge with data sources is if you find a good website, and I encountered this with the electric vehicle, they detailed several websites that they scraped for this data. And when I went and looked at those websites today, none of them exist. They're all gone. Or the ones that do exist don't publish future forward data anymore, probably because they realized that that data is valuable. But you can use web archives to go back and find the data that was there at the time. So I think, maybe I don't have a great answer for that, but the way that I've categorized that is you have this very kind of academic future facing literature, news literature, and then the massive web of stuff that's out there for people that aren't actually monetizing their data.
Great, thank you. Unless there are more questions from the committee, I'd like to open it up to the audience, and I suggest the best way is probably you simply put your question in the chat. If you have a question for Chris. Or if you are comfortable unmuting yourself, of course, you're also allowed to unmute. So there's a question, fascinating topic, is SAAM open source or proprietary?
SAAM is open source. In my dissertation, I described it thoroughly, exactly how I built it. And the pieces of it are, I haven't cleaned it up and open source it yet, but the pieces of SAAM will be open source. And all the components are open source. None of it is proprietary at all. So if you wanted to reassemble it from scratch, you could do that based on the descriptions of it.
Tim?
Okay. A great presentation. Very much enjoyed it. Not just the content, but also the presentation style. So everything was great. Even the broken lamp was nice. So, so in some ways, this reminds me of, makes me think of factor analysis in a much richer and more complex domain. And a common problem in factor analysis is naming the factors. Does this approach name each of the scenarios? And if so, how robust is that naming approach? Or is that something that you have to go in and manually do? And if so, how, and if not, if you use a automated name, how often do you need to tweak it to really make it make sense to a human afterwards?
Yes. So with fuzzy cognitive maps, then this is certainly part of the manual process is coming up with a name for it, but almost a pithy name so people can understand the scenario better. So even if you go back to the smart port scenario, where a concept could be the increasing automation. So in your what if scenario, if you set that to high and run your model, really what you get is a series of values of your concepts. So speed of supply chain could be like, a number between -1 and 1, 0.5, 1, 0, whatever. And then really kind of the step after that is looking at those values and then turning them into a narrative. So as a person, you'd run the what if scenario, you'd look at it and you'd say, oh, well, in this scenario, supply chain was drastically increased because we increased automation, or in this case, the supply chain got gummed up because no one entered the workforce for 20 years. So then, the way I've seen other authors do it, and this is the way I've done it myself, is after you run the scenario and you look at the results, usually just give it a label, like the deregulation one as an example. So in that case, I could describe all the different concepts and their values that I set and the outputs, but it's so much more, it's easier to comprehend when you kind of look at it and you say, well, in this case, my goal was deregulation. In the case of deregulation, this is what happened. So that part is still a bit of a manual process. I mean, in theory, because you do have these concepts and you know what they're doing, you could probably use some kind of language generation to turn them into something. But I would argue, actually, coming up with the names is kind of it's kind of fun, actually. And I think that if teams are doing this, I think it's a good way, that's my opinion. I think it would be a good way for them to kind of process the information more.